Okay, so we'll go ahead and get started then. I know, so welcome back to workshop number 2. I know you guys have been dying for this next installment. I could tell from everyone having great SQL dreams and instantly hitting the workforce right after the last one and showing your value to everyone. So it's exciting to build off that. So for today's agenda, what we're going to do is we're going to do a review of workshop 1, because you can never, as you're learning these things, these are very attributable skills, or trails or skills that will attrit over time. So it's always beneficial to keep going over them, quick what ifs or quick what does this mean, and then from there we're going to start diving into today's lesson. Today's lesson, really, we're only going to introduce one new concept. We're going to be building off the ones we learned off last workshop, but we're only going to introduce one new one, because the new one that we're going to be introducing today joins connecting multiple tables to result in one data set. It's going to require multiple pass-throughs, and it's a concept that could take a couple tries to really grasp. All right, so it's going to kick it off right with the workshop. So our favorite, select all from any table in a data set. Again, arguably, like if you know this, if you could do this and then throw on in the next slide, we'll go over how you can modify this slightly. But if you could do this, you will be able to get data from a database. Now it's not going to be fun for you to sort or organize that data outside of that database. But if you could do this, you're hitting the bare minimum of extracting data from any database that you have access to. Now, what are some advantages of this? I kind of gave away the big one, but are there any other advantages that we could think of? I mean, I think that's it. Like you could always extract data. You'll always be able to extract data from any table. That's the biggest advantage. Okay, yep, here's some other ones actually. So we can familiarize yourself with a schema. So if we're building long and complex queries, we can easily just select all from a table, familiarize yourself with the schema. So as we develop this longer and more complex queries, we know exactly what columns we can pull in from what tables. And then of course, once you export, when you export the data, you can put it into Excel or another tool and conduct further analysis. Now, here are some disadvantages of a select all statement. So like the benefit of pulling all the data, that's also a disadvantage. It pulls all the data. So if it's a table that has hundreds of thousands or even millions of records, it's going to take a long time and it's going to be very expensive. Computing power is going to cost a lot. The time that you're sitting there as the query clock is just thinking, it's kind of annoying to just sit there sometimes and wait 3, 4, 5 minutes for a large query. So actually, what can we do to this statement? What can we add to this statement to help make this more optimal, to make this more refined, to make this better? You guys remember what word we put or what statement we add to this query to kind of help us out here?
Maddie, was this order?
This is before order. Order, I think, how do we filter? What statement can we use to filter data?
Is it the where statement?
It's the where statement. That's exactly right. So we can filter using the where statement. So, and what are some use cases for this statement? So going back to the data set we have access to, we're looking at the data of a film rental company. So instead of pulling all the films, we could say, give me all the films where rating equals PG-13, or give me all the films where release date is 2006. Going back to the statement, there are lots of use cases, but what the where statement really does is it narrows the query's search and the results from that query, and it really refines and optimizes the data set that you're looking at. So no longer are you, during that result, when you get the results back from your query, no longer are you just going through all this, could be hundreds of columns in your result. You don't have to go through all the useless columns because you put the where statement or the record, you put the where statement and it reduces the records to only what are applicable to your question that you're asking. And then here are some of those operations that we went over last workshop. These are some of the things that you include in that where statement. So where title equals this title, where release year equals this year or is less than this year or greater than this year. In that last column here, here's some great examples for the use of these operators. And then actually in the chat, I will go ahead and put some pictures on because these will probably be useful as we go through, continue on this workshop. Having these pictures handy. So there's one of them. There's two. And there's three. So you should have three pictures available to you in the chat right now. One of them is of this operator table. The next thing we went over last workshop are the when you combine where statements into a single row. So where release year is 2006 and rating equals PG. You can actually combine these filter conditions into a single clause to help even further narrow down the results that you're getting. And again, the last row is going to be some examples of how we use these last workshop. Okay, math and aggregation. We covered this a little bit last time. Does anybody remember what functions we went over in the form of aggregating some fields?
Group by.
Group by, yeah. So that's how we make sure that when fields are aggregated, we're putting them in the right, we're aggregating according to the right attribute. So some of those things that we were aggregating or one of those functions are, we could count a field, count the records in a field. We can average numbers in a field. We can sum numbers in a field. Now it's very important that exactly what you said, group by. Without the group by, the result is going to be a single record, right? Because if you're saying, give me the sum of this field, it's going to sum all that field and give you a single result. But if you want to sum by category, that group by statement, which we will cover next, is extremely important. And I know it might have been a little confusing to kind of grasp this last time. So I found this really, really nice picture to kind of visually explain what is actually happening when you group by an attribute. So in this picture, we have just the table, it references incidents. And what this little query snippet right here is, it's grouping counts by ID. So this first column here, this first field is ID. You could see we have a couple repeats. So we have 2, 3, 4, and then 2 again. And then what this statement is going to do is it's going to give you a count of records, records a row. It's going to give you a count of records by ID. So right here, we could see that it's actually aggregating that count. So when it's ID 2, we have 2 records, just as outlined over here. We have 1, 2. So this is kind of why the group by statement is important. Without this group by statement, it's going to give you 1, 2, 3, 4, 5. It's going to give you a single row with a count of 5. Now, when you add that group by, it's grouping by that attribute, and we could see the result here. Okay, and then here's the query structure. So this is clearly out of order. What is the correct order here? Who can talk me through the correct order as we learned last time in the workshop?
I think the first one would be select.
Yep, select
You know where
them.
you're pulling from, and then I think from would be the second one.
Yep. Yep, so there's only 3 left.
I think where would be next,
That's correct.
and then group by, and then order by.
That is perfect. That is exactly right. Yep, that is exactly right. Very nice job. Perfect. So that was a quick and dirty run through of the last workshop. And now we get to go to the new material. And then if you're a big fan of comics like I am, this is a great SQL joke. So a query walks into a bar and sees 2 tables and walks up to them and says, hey, can I join you? Which is what we're going to be learning today. We're going to be learning joins. Last time we kind of talked about what a relational database is. So why is this a concept? What's it mean? How does it work? And what this actually means, the value of a relational database is that each table within it is designed to talk to another table through a key or like value. People call them different things. They're primarily called keys. Simple, if you could just think of like values. This value is the same as this field represents this field in a different table, and we just have to connect them. So between these 3 tables, each one of these columns represents a table. How would we connect rental to field or film, excuse me? How would we connect the rental table to the film table? Anybody want to give a guess?
I have a guess.
Yeah.
So we could connect inventory ID from the rental table to the inventory table, and then we could use film ID to connect the inventory table to the film table.
Yeah. Does everyone else think that's right? Does that look right? Anyone else got a different answer? It's the right one. So excellent job. Now, this looks great on a PowerPoint. It briefs well. We could talk through it when it's in columns. We could visually see that. But let's ground this. Let's reference something that most of us have experience with. Excel. So in an Excel workbook, you typically have multiple tabs, and each tab represents a sheet. And there have been multiple times where the data on each sheet represents something different. But now there is a specific technique that most of us use when trying to pull or match data from the first sheet to the second. And that function is typically VLOOKUP. If you're a little more savvy on Excel, it's match index, but VLOOKUP is what most people use. So you're telling Excel to go to this table, look for a value that's similar to the one in the table you're working in, and then bring over a separate field when it matches. And that's what we do with joins. That's essentially the same thing as what we do in SQL. Now I'm going to post this picture also in the chat, because this is actually a very handy picture whenever you're doing SQL or starting off, to kind of guide you through what the different joins do, which we'll jump in deeper here in a second. It also gives you the SQL snippet and kind of helps you better understand through visualization of what the data is actually doing. So let me pull it from here we go. We're going to put this in the chat. Perfect. Now you have this picture to reference as we start to build these queries later in this workshop. But to jump in it right now, you'll see some common themes, right? So you'll see left join right here. You'll see left join right here. You'll see a right join right here. Going down, you'll see a right join right here. You'll see an inner join right here. These 2 joins down here, they're absolutely a thing. Most likely, you'll never be in a situation where you need to use them. So they're here on this picture as a reference. We're not going to cover them in this workshop or the next. And actually, you'll, like I said, probably never be in a situation where you need them. So for the top ones here, the 2 common themes are a left join, and a right join. And those, as long as you know those, you'll be fine. You'll be able to connect any tables in any situation that you will come across and get the right results. Now, looking at this diagram, if anyone's taken statistics, what does this mean? What do we think the data that we're going to get as a result of a left join is? Who wants to take a stab at explaining the data set that's going to be a result? I'm going to call on somebody. Josh, do you have an idea?
To me, it's only select A. It's nothing about B.
So could you say that again? I'm sorry. When you do this, it's.
You mean the first one?
Yeah,
So,
this one right here.
yeah, I think it only select A and B is, I don't think it's matter because like it's only A which filled by the wrap.
Okay, yeah. So what about this part right here that's also B? Do you think that's going to include the B records from the overlap?
I think so.
Yeah, that's exactly right. So a left join is going to give you all the records from the left table, and then only the records from the right table that overlap. So you get all of A and only B that matches A. On the right side here, it's the exact opposite. On a right join, you're going to get all the records from the right table, and then only the records from the left table that overlap that with B. Now, what is it matching on? What records is it actually going to pull? That's exactly what we're about to dive into. So from that picture we just went over, this is an inner join or just a join. You could put inner in your query. You don't need to. I never do. But this is a great visualization of what is happening when you just do a regular join between two tables. So you have the left table right here in the right table. And if we go back to the picture, an inner join is going to give us records that only overlap, only records from A and B that match each other. And if you look at this visualization, that's exactly what's happening. Line 1 and 3 from the left table, or excuse me, IDs 1 and 3 from the left table only match IDs 1 and 3 from the right table. So the result will only be IDs 1 and 3. Are there any questions right here? Does everybody see this, or is there any questions around the concept for the inner join? Okay. We're going to go to a left join. So a left join is probably going to be, yeah,
Can
go
I
ahead.
ask you, can you go back to the previous slide? How do they know? So like we don't need to clearly indicate that we want to use ID as the criteria to join. When they compare the two tables, the computer will automatically understand what overlap to join.
Yeah, that's a great question. We should have touched on that. So on the left-hand side here, we see the query, a basic query construct of how to initiate this join. So I've underlined the last line, right? So it's this part right here. So after the select statement, you go select whatever you want from some table. You now need to add a join statement to say, we've already identified the primary table. I want you to join the secondary table. This is what I want you to join it on. So you can see it goes join right table on, and then you identify the value from the left table and what it needs to match from the right table. In this example, it's ID. So we would say, join the right table on left table.id equals right table.id.
Okay. Want to merge, to create a new table with ID from 1 to 6, we will use different command like merge, for example, right?
Yeah, could you rephrase that question?
I mean, so this is join, but if we want to merge to create a new table
Yes.
with the ID list from 1 to 6, we will use another command.
Yes, we would use,
Okay.
we would use, if you wanted to include IDs 1 through 6, we would use a different join to do
Okay.
that. Here is a left join example. So actually, I think we might even cover like a full join. To answer your question, that's exactly how we would do that. But here is the example of a left join. So we're saying, remember that picture that we just went over? We're saying, give me all the records from the left table. Give me all the records from the left table and only the records from the right table that match. And in this example, you can see we have the left table, which is IDs 1, 2, 3, 4. And then give me only the records from the right table that match. And then you can see we have 2 matches. We have 1 and 3 that match left. So the result will be all the records from the left table, 1, 2, 3, 4. And then you could see in the first column, we have the values from the left table because I said, give me all the records from the left table. But on the right table, the second column, I only have the values from the records that match. So I have a record, or I have a value for ID 1 and I have a value for ID 3. ID 1, ID 3, because these are the only records from the right table, ID 1 and 3, that match the left table.
Maddie, can I ask a dumb question?
It's not going to be done, I promise.
So it's not looking for an exact match because you've got L1 and R1. Does it consider it a match because it's both got 1? In the real world, would that have to be an exact match all the way?
So what we're telling the system to look for in our query over here, we will dive deeper into this. Right now, we're just trying to outline the concept of what the system is doing.
Okay.
But how we tell it to do that is through this statement right here. I'm telling in the query, I'm telling the system, I want you to give me a left join. I'm telling you to do a left join.
Mhm.
And how I want you to do this is on the left table, I want you to take some value, which in this instance is ID. I want you to take ID, and then I want you to look at the right table. And in this instance, it's also called ID. So I want you to give me all the results where the ID from the left table matches the ID on the right table.
I see. So it's the 1 and the 3 that it's looking to match, not the L1 and R1.
Yes, the first column here, the ID, the colors right here, blue, yellow, green, red, and both sides. That's the matching criteria. That's the
I see.
criteria we told them to match on. So like when you're doing your VLOOKUP and you're saying, look at this column, now go to the table, go to the second table and look for this column, but I want you to give me a different value of that same row. That's what this is.
Got you. Thank you.
And because, let's look at this way too. So because the right table doesn't have a 2 ID, an ID of 2, the right value is going to be null because there is no value to give us.
Got you.
So in the right
How do you-
join, go ahead. Yeah.
Oh, sorry. I have a question and it might be jumping way too far ahead, but
Yeah, go ahead.
what would happen if you have if those IDs that you're trying to match are not unique? Like maybe you didn't realize there's a duplicate and so the right table had like 3 number 1s.
Yeah.
Would it just not work?
No, it would totally work. You would just get results that you weren't expecting. So that's a very important call out. And I don't know, I purposely did not include that in this workshop. We will include it the next one, but we call that a many-to-many relationship. So
Okay.
think of it, I actually think I have a picture because it was so important. I'm pretty sure. Yeah, okay, here we go. So I dropped the picture and, oh, it didn't work. Give me a second. Okay, here we go. Give me a second. It won't let me drag and drop right now, so I have to manually select it. There we go. Okay, you should have access to it now. Let's see if I can throw in a quick slide with this picture, actually.
Okay, this is
Okay.
helpful.
Okay, perfect. Yeah. So this is what happens when you have a many-to-many relationship. Now, the disregard the top part. Just pretend like the right column is also the same or like different. But this is what a many-to-many relationship results in. You're going to have, like you asked, what if there's 3 of the first one? Well, it's going to match all 3 with the results in the second table. So what it's doing is it's producing duplicates, right? And that's not something you want. So if you're looking for unique IDs to match to a particular, so left joins or right joins start to lose value when it's a many-to-many relationship, because you will get a lot of duplicates. And then when you try to aggregate in these duplicates, it's going to grossly inflate your results. And people are going to look at you like, why is our loss this quarter 3 million instead of like 3,000? Well, it's because you have all these duplicates because of a many-to-many relationship that result in extreme amount of over aggregation.
Got it.
And
So usually, sorry, just to make sure I
Go ahead.
understand, usually we're just doing joins when it is a unique ID because it loses value, right?
There are ways to, and we'll cover this next class because
Okay.
there are ways to, if you know, if you already know that it's going to be a many-to-many relationship, we could deploy certain functions and filtering techniques to reduce that table and eliminate those duplicates. We can use a combination of distinct, group by, max, min on particular fields that will result in a unique, very distinct set. And then we will use that as either a CTE or a subquery and combine that with whatever our original question is. So that's getting a little ahead of this, that is ahead of this workshop. That's something we absolutely will cover next workshop, or subqueries, common table expressions, and how to build aggregated tables and then combine those aggregated tables.
Awesome. Thank you.
And then here is a full join. So a full join is going back to the picture. It's saying, give me everything from both tables. I understand that everything's not, table 1's going to be not going to have things that table 2 has. Table 2 is not going to have things that table 1 has. So there's going to be nulls. I anticipate nulls when doing a full join. But what it does is it will give me all the data from both tables in a single view. And then you can see again, because table 2, the right table doesn't have an ID of 2, it's going to have nulls. Table 1 doesn't have ID of 5 or 6, so it's going to, we see nulls for 5 and 6. You won't really need to use this in a lot of situations, but it's good to understand what happens when you do a full join. Okay, so, and then this is the query structure, right? So this is what we're telling the system to do. We're saying, here's the table here's the main table I want you to go. So that's this first from statement. Here's the main table. Here's the table I want you to connect to. And I want you to connect on these 2 fields matching. So this is what a join statement in a query looks like. And we're about to jump right into one. Okay, time to explore. This is a great joke. So I invite you all to write this down and go to one of your classes with all your very cool kids and say this out loud, because it will get a laugh. Don't worry, I'll send this out so everyone has it. You don't have to write it down right now. Okay, so go ahead and attach to the Foster Virtual Lab. Here are the instructions. So before we talked about what a relational database is. We had this example earlier. We have these 3 different tables. We're trying to connect rental to film. We know how we could do that. We could do that through pairing of key IDs in each of these tables. And then using these key IDs and connecting it, combined with the join statements that we just reviewed and the clauses, we can produce a pretty sophisticated query to tie rental data to film data. So here is an example of a query that does just that. So if you have access to the MySQL server, if you're able to connect, go ahead and just type this out as a query, and I will share my screen, and we can do this together. And I have an error because I messed something up. Line 5. Oh, right there. Oh, that's right. Inventory, I need to join film actually. So, okay, so the slide is incorrect. Oh wait, no, it is correct. Sorry. Inventory. Okay, sorry about that. That took a little longer. If you can see my screen, this is the correct query to put in. So we're telling the system, this is my primary table. Give me all records from rental, and then give me the records. And then we're connecting rental to the inventory table, just like in the slide. On inventory ID is equal to inventory ID. So that's a pretty easy one to see between the two tables. If we go back in the slide one, we could see the keys structure here. And then we're saying connect the film table to the inventory table on film ID. And when we do that, it's going to give us all data from all three tables. You could see how this results in a lot of data, a lot of columns. Some instances, a lot of repeated data, because we have rental ID, we have inventory ID right here in this column. And then we'll have inventory ID again, because it's in the second table. And we just have a lot of data here. All right, so moving forward with the slideshow, let's refine our query a little bit more. Let's not just say, give me all the data from these three tables. Let's actually ask a business question and try to derive the solution to that business question. So our business question is going to be, what film rating generates the most revenue? Right here, this is going to be the table structure. So this is like already a hint. These are the tables, like it's already been mapped out for us. We already know that we're going to need these tables to get revenue amount by film rating. Now we just have to understand what the key structure is between these tables and what columns or what fields we will need from each of these tables. So we'll actually work through this together. Yeah, just going to do that. We'll share. And if you guys haven't, cool trick, if you haven't already figured out, you can always open new queries. So you could save old ones and always reference them as you're developing queries. So we're going to save this one here so we can reference it. And then we're going to build a new one. And the slide actually already has the answer, but we're going to talk through this. So the business question is, what film rating provides the highest grossing revenue? Like, how much do each of these ratings result in revenue for us? Like, is PG-13, is it R? We can come up with a hypothesis, but it's better just to get in here and write the query and have the query give us the answer for us. So as you familiarize yourselves with these tables, you'll see, you'll get used to the structure and the schemes of these tables, and then you'll identify what tables have the right data in them. So looking at the film table, we know that's where we're going to get the rating because we worked on that all last workshop. We know the rating lives there. We know that the rental table, based on the last query, is going to have the rental data for us. And then looking around the other tables, like if we're trying to look at revenue, the payment table, if we dive in there and we look at it, is probably going to have the payment information required. So we could actually just go into tables, go into hit payment, and then check this out. And we could see, okay, yeah, so here's actual payment information based off of rental ID. So we know that these are the three columns. We need rating from the film table, we need rental IDs from the rental table, and we need amount for the payment table. So now that we understand the tables, the flow, the keys that connect them, we can start to build this query. And then you can see that I'm doing some things that we haven't recovered, or we haven't really covered yet. We kind of covered it last time when we were talking about aliases and shorthands. We will dive into this a little deeper here in a second. And you could already see the benefit if you are using the aliases right now. You could already see the benefit of what the alias does. So as I'm writing these join statements, it's actually creating shortcuts for me. So I don't actually have to keep writing out these long phrases. It'll auto-populate a lot of options for us so that we could just select from those options. Okay, so was anybody, so there's probably a lot of questions about what's happening here. Did anybody hit any errors? Did they try to build this on their own? Were they following along? What are some of the questions that are popping up right now? You could see the results, and we'll talk about these here in a second, but I really want to dive into the structure of this query. I want to talk through how we put this together, what it's actually doing.
I have a question. And
Yeah.
sorry, you might have gone over this when I was trying to get it set up, but under the select, under select, you have parameters of the specific data that you want to include. And it looks like the shorthand for referring to different tables is just the first initial. Is that like a name that you've already pre-established, or how is that?
Yeah, absolutely. So great question. So how do we identify, or how do we assign aliases as the question, if I'm hearing correctly? Like where did this F come from? Who said to use F? Why is this a thing? So ultimately, the alias can be whatever you want it to be. So if you're following along with my screen in the query, we can actually change this to ice cream. Right, we could change this alias to whatever we want. Now, I wouldn't want to change it to ice cream because that's actually longer than me typing, film. But essentially, it will still work. So I can run it. Yeah, so ice cream is here. That's because I have to change this now. Okay, there. And now it still provides the same results.
Okay, so the shorthand is determined in the query itself.
You get to define what the shorthand is. You get to define what the alias is. You define that.
Okay.
So it's whatever you feel comfortable with. I often think it's, I always veer towards the first letter of the table, or, if it's 2 words, the first letter of each word in the table. Because then I could look at it and intuitively say R, okay, well, that's rental. I is going to be inventory, P is payment, F is film. Because as we start to develop these long queries, and next workshop, as we develop these subqueries and CTEs that are just, massive, you definitely don't want to have to keep typing everything over if you don't have to. And it's, change this back to F, and change this back to F. And it's just easier, right? So it's whatever the alias is, whatever you want to define it as. And the system is smart enough to know that if you name something, it will remember that throughout that query. So up here, and we'll cover aliases more here in a second.
Okay, thank you.
Yeah, any other questions of how this is? So, typically when you're working in Excel and you're using a VLOOKUP or a match index, you're only going one table to one table, right? You're going from tab 2 to tab 3 or tab 1 to tab 2 or vice versa. In this query, we've actually jumped a lot of steps in this join sequence. So I didn't give you just one join to work with, because usually you're not going to have it. You're going to need to deploy multiple joins in a single query. So in this query, we have 3 join statements and we're connecting 4 different tables. So it might sound hard to do that, but if you look at this is actually pretty intuitive and it flows really well. You put your aliases there and it really, it's not as bad as what you might have thought walking into this, right? So you connect the like values or the keys in each table. I'm saying go to rental, and I want you to connect rental to payment, and I want you to take rental ID from the rental table, and there's going to be a rental ID in the payment. They're going to match, give me all the data that matches. Now this group by, we keep going back to the group by because it's very important, right? So without this group by, actually, let's just look. What would happen without this group by? What do we think is going to happen? Anybody have an idea? If we're not telling it to group by a specific attribute, but we're telling it to aggregate a whole column, what do we think the result's going to be? Elizabeth, do you remember what happened last time?
I think it just aggregated everything, so it's kind of meaningful.
That's exactly right. It's gonna give you one record result. If you don't have the group by, it's going, you're saying count all the records here, sum all the records from this, and it's just going to give you a single value because that's what it thinks you're asking it to do. Now, if we do group by and we're grouping by this attribute, this dimension rating, now you're saying, okay, here's a list of things that I want you to count for and summarize with.
Matty,
Yes.
can you explain to me why it is grouped by one? One here means the first column.
Yeah, great question. So this is the shorthand we learned last time. So
Okay.
this is the same thing as saying f dot rating. What we're telling it to do is I want you to group by the first column that I'm telling, or that you're asking for. Now I could do this. I could move this down here and say, and instead of it being grouped by one now, what would it be? What would I now change this to?
Group by 4.
It would be, think of this as the columns, right? So
Okay,
if I'm telling,
3.
yeah, 3, perfect. So I'm telling it to group
Quick
by
question, but if you have a vacant rows, blank row on the second row, like the previous one, what will happen? Nothing happen.
if
It's still 3.
if I had that, if I did that,
If you keep a blank row right
if
below
I
the
keep a blank
select,
row, nothing's
Yeah.
gonna happen.
it's still 3. Okay.
Yeah, nothing's gonna happen there.
Okay.
Right, so the system is smart enough to understand that just to skip it. Now, you could also run your queries with all the columns on a single line. Like the system will also work like that. I don't recommend that because as you build, again, as you start to develop these big queries, it's going to be very hard to navigate and troubleshoot if everything's on one line. So if you, by separating lines, if I were to ever get an error, so let's just remove this. Let's remove that shorthand. And let's try to run that. Oh, actually, okay. That's that example. Let's just mess up the name completely. It's going to give me an error. And now the system is going to do its hardest to direct me to where that error lives in the query. So we can see in the message right here, unknown column f dot aiding in field name. And it's going to give me, it should give me like a row number. Usually gives me a row number, but at the very least, it's going to tell me where the error is, what the error is. So now that's going to very much so help me identify it in this query. So it's very, like, for me at least, I separate them because if I do mess up somewhere, the system will help me and I can better identify where the error is and fix it.
Hey, Maddie, I've got a question that's back on the aliases.
Yeah, absolutely.
Maybe I'm missing something, but in the sum on line 4, you say p dot amount, and I think later on line 6 we use p again. Is that setting up an alias? And I guess it looks different than like what we did on line 5. So how is that working?
Yeah, so let me see if I heard the question correctly. I'm trying to get this so we can see everything here. So on line 3, are you talking about line 3?
Yeah. Right
Okay.
there. Yeah.
So, so this is the alias. Typically, as we learned last time, what we should have, or what we learned last time, is we have to type the entire data set, and then we have to type the entire table, and then we have to identify if we're looking for specific columns, then we would select that column. So we would be looking at that. And the function, the aggregation, we would surround, we wrap it. So that's what we would do if we didn't use shorthand, but we are using shorthand, and we have established that shorthand down here. When we join to that table right here in line 6, we have to say the table that we want, and then we assign it that shorthand. So this is, yeah.
Yeah, so I guess it's okay that we've established that shorthand after using it prior to establishing that.
That's exactly right, because you establish the shorthand where you identify the table. And we're identifying the table in this join.
Okay, thanks.
Perfect. And now what we are going to do is I think we go back to the slides and then we jump right into. Yeah, I'm gonna stop sharing the screen. We're gonna jump back over to the slides and then hopefully this will help answer some more questions. So table aliases, all right? So the alias always comes after the table name when you've established the table in the query. So when we're joining multiple tables, that's when we establish the table name. And then that's where we assign the table alias, the shorthand. You could see in the example that we just ran together in the workbench, and you could also see it here in the slide, right? So after I say from rental, I establish the alias R, and then you could see in all my joins, instead of saying Sequila rental, I only say R. And the system understands that I've assigned the alias up here. So when it reads it down here, it knows that I'm talking about the rental table. And here we are again. So we've established the table alias and we can see how it worked in the joins. The table alias also, just like we were asking, also works when we establish our columns or our fields in the select, just under the select statement. So once I tell the system, I want to forever call this table R, it will be able to look at the columns I'm asking for and see that I'm using that same alias in my columns. The system is that smart. It'll just understand. Now we also deployed something else, right? We deployed column aliases. So we established table aliases, and now we're also deploying column aliases. And you can see from that query that we all wrote together, the results, the column headers are those aliases that we establish in the query. So this is just a snippet from the query we just ran together. You could see the highlighted or the bolded parts of each of these rows or each of these fields that we're requesting. That's the alias that we've assigned to it. So we are saying for the film rating, I want you just to call it rating. For the count of rentals, just call it total rentals. And then it's not review as the slide says, it's supposed to be revenue. But you could see if we assign it here, it's going to appear as the column header in your results. So this is important because when you aggregate data, if you don't assign an alias to it, it's going to look weird. And if you give those results to somebody else to look at, they're not going to understand what that is. So if we actually hop back over to, let me share my screen. And then we remove this name. Okay. Okay, line 5. No, right there, left the comment. Okay, so if we remove that alias though, what's going to happen is it's going to give you this. It's going to give you what the command actually is, sum p dot amount. And if you print this out, you hand it to somebody, they're not going to really know. So by giving it alias, you're cleaning up the results and you're making it more user friendly to anyone else, including yourself as you review it. Okay, we're running out of time, so we're gonna hop. We're gonna speed it up a little bit. We might not get to the last question, but I think we've got enough to kind of understand this. So, all right, so here are the results. We just ran that query. Here are the results. Now we start to get back in the business mindset. The business question is what ratings generate the most revenue? You could see here the revenue earnings by rating. we could see that PG-13 and NC-17 are the highest two revenue producing ratings. What are some things we can infer from here? What are some questions that this will drive us down a deeper analysis rabbit hole, right? So like, you're looking at this, you're trying to make smart business decisions for this film or this video rental company. What would this prompt you to think about? Anybody who has any thoughts, just go ahead and shout them out.
I think I'd want to know the average revenue per rental instead of just
Okay.
these totals.
Yeah. So that would be another column, right? So if we can actually go and let's look at what that is. So let's share the screen. Oh, sorry, actually you're sharing. So we can actually add a new thing here, and we can actually just cut and paste. We can go sum of rental or sum. Oops, that didn't really work, did it? Oh, great. It pasted the Slack meeting. Okay, we're going to delete all this. Okay, we're going to delete this. Okay, so we can actually do that. So we're going to go the sum of p dot amounts divided by the count of r dot rental ID as average per rental. Okay, so here's your average per rental, right? And then actually, let's just round this to 2, so to make it nice and even. Okay, so here's your average per rental. What else? What would you do with this average per rental? What else could this information help drive? How about like, now that I know what works and what doesn't work, maybe investing more in PG-13 movies, because there is the movies I have, maybe they've seen them 100 times, but I know that people want to rent these movies, right? So maybe I buy, as I increase my inventory, I focus on PG-13 and NC-17 movies. Something else to think about, maybe G-rated movies are so low because there's not enough of them, right? Maybe I only have like 3 G-rated movies and they're always being rented, but no matter how often I rent them, I just don't have enough of a supply to increase my revenue as much as like a PG-13 movie, right? So there are a lot of questions that you could start asking further on this, and then dive deeper into the data, because now you have access to the data. You're able to go in there, you're able to write this query, join these tables, get these results, and you could start thinking like a smart business maker or smart business decision maker and diving a little deeper. Right, so let's see, we probably don't have time. Well, okay, we're gonna run through this. We'll just do this together. So here's the next business question, right? So the business question is, what are the 10 largest revenue grossing film categories? All right, so category is another table that we haven't dove into. And then how many times have those films been rented? So of all the films in our inventory, what are the 10 top revenue producing categories? And then how many films have been rented in each of those categories? So the first step we're going to do is we're going to visualize what the results are supposed to look like. When we're starting to look at large data sets like this and we have to connect multiple tables, it's very important to understand what we think the results are going to look like. So based on that business question, I think this is what the results are going to look like. I think I'm going to have a column that's category. I'm going to have a column that counts how many rentals occur for that category. And I think I want a column that tells me total revenue. Okay, so yep, I think about it. That looks right. That sounds right. That'll answer the business question. That'll allow me to dive deeper into research if needed. So I need to build a query that will give me values for these 3 columns. So now that I've completed step 1, I've kind of painted out, I've mapped out what I'm looking for, I can start to develop my query. So step 2 is Okay, I know what it looks like. I now need to figure out what tables I need and how those tables talk to each other. So I know I'm looking for category, and I know I'm looking for amount spent. So we're going to build off that last query. So we already know that we just did this part. So all we're doing in this query is we're adding these two tables. And now we can just build that query. So if you already have that query, if you still have that saved query left up, you can just add what is needed from the query in the slideshow. Actually, let me make sure we're doing this correctly. Just to recap for the recording, this is the business question. I was sharing my screen before, moving back to the slides real quick. What are the 10 largest revenue grossing film categories? The first step is to identify what we want the results to look like. The next step is to identify where the data lives in our data set, what tables, and then we have to identify how each of these tables talk to each other. This was the query we just ran together. We just need to add these two tables, and then we build the query, and here's the built query. So if you already have that query saved from the last time we just ran it, we could just add what's missing. So we know that we need to add those last two tables. Here are the joins that we need to add. SQL.film category. And then Elizabeth, to your point, like now you see for the shorthand, we see FC here for film category. That's just the first letter of each word that I made, because now I know that that's my memory cue. FC is always going to be film category. But again, it could be anything that you want. Yeah. All right. Bye, guys. Thanks for hopping in.
Thanks, Maddie. Appreciate it.
For those who left, we only have like 5 minutes left, so bear with me, and this will be, we're going to take this a step further right after we all get on the same page with this query. And up here, this is going to be. Okay, why? We're going to share the screen again, and we'll talk about what we're seeing here. Okay, were there any issues from anyone trying to replicate the query that's on the screen? Take silence as a no. Perfect.
Can I ask you at the end of the section so that I don't bother other people?
No, ask right now. Go ahead.
Oh, actually, when I just opened the MySQL Workbench, there is a kind of pop-up window, SQL additions. Automatic context help is disabled. I mean something, and I cannot close it. And But maybe because I missed the first session, so I will just watch the recording later.
Okay, yeah, we can
Yeah.
talk about that at the end of this, sure.
Okay, thank you.
So for everyone though that's still around, still following around, so what we're asking for based off the slides is we said we're looking for the top 10 categories, right? What categories producing the most revenue? So we have category name, we have how many rentals in that category have occurred, and then the total revenue generated from that category. And here are the results. And then we're down here, we're telling you to group it by category. I want the highest revenue producing categories up top, and I only want 10. So I actually put a limit. This is kind of new, right? This is the first time you guys have seen this, but what this does is this statement limit, and then the number after it limits how many records are going to be in the result. So I asked for 10, it gave me 10. So now I'm looking at this, right? So the business question, again, how many categories or, top 10 categories. Now I'm looking at this and I'm thinking, well, the query we just ran told me that the top 2 ratings are PG-13 and NC-17. So I would like to know how many of these, how much revenue from these top 10 categories are produced from those movies. So how do we filter? Everyone remembers how we filter? What's the statement we use to filter data?
Where?
It's the where, yes, absolutely. It's the where. So we haven't used a where statement today for our join clauses, but it absolutely works here. So we're going to do that. So I want to know how much of this revenue is being generated from movies that are rated PG-13 and NC-17. So we're just going to go ahead and add that statement here. Now, NC-17, if you're familiar with American cinema, is typically not an average rating. So when I'm looking at the results before I enter this, I'm getting kind of scared because I'm seeing family, I'm seeing sports, and I'm kind of wondering, how is NC-17 such a highly revenue producing rating that I'm looking at categories and I'm not really connecting the dots. So let's go ahead and run this query. And now I'm even more confused, right? So like if we look at the top 10 and we're looking at the rating comparison, at the very last result is the category of children. So I'm really concerned that there are children categories that are rated NC-17. So as I'm doing this is something I would bring up with my manager or the owner of the store. I would ask, these are either incorrectly categorized, they're not in the right spot in the store, or these are movies that you shouldn't have, right? We should not have children movies that are rated NC-17. So we've actually identified a discrepancy in the data, or we've identified a true business problem that should be immediately addressed. So this is a fantastic real life example that could happen, unfortunately, that would need to be looked at. So going back to slides, we'll close out real quick. We talked about this. This is what I was talking about. We saw the last results, PG-13, NC-17 were the highest producing ratings. So let's look at the categories. And now we add the ratings to the categories. And then this is what's concerning to me. Why are there family and children movies that are rated NC-17? We should resolve this immediately. Okay, so the most important thing to always remember though, if you ever forget anything in SQL whatsoever, like anything, like if you forget how to do left joins, you forget how to do right joins, you forget what operators are, less than equal to, you forget what order to build a query, when in doubt, just Google it. The best website to go to is going to be Stack Overflow. Stack Overflow is a, open source, not open source, it's a consumer-led, open platform that's, I ask a question and other users will answer it. They have SQL tags, so you can specifically type SQL. And here's some great examples, like we talked about. This first one, the group by, this result actually goes pretty deep in a group by. The pages are going to look like this. This is a user response with just under 2,000 thumbs up, which means this is a really good response. So whatever this question was, it looks like it was using the case feature, which we will be talking about next workshop. It's an if-then clause kind of aspect. So the Stack Overflow is always going to be great. Whenever in doubt, Google it. We won't dive into this. We're already over time. I don't want to keep you guys anymore. So here's a great little joke, as we know. Other than that, what are any final thoughts? This is it. This last slide. Next Tuesday, same time, same place. We'll go over the final, more extremely more sophisticated aspects of SQL. But as you guys have seen, nothing's overbearing. It's pretty intuitive once you understand the concept behind it, and it flows exactly like it should. Any closeout questions?
Yeah, I have a question. So I never got it to I never got on. It didn't work. Is there a way for me to practice this and walk through it on my own, or do you have to start the server?
No, this is something that everyone has access to in their own time. No, so what we'll do, Elizabeth, is we have the contact information for the IT people, and if you had any issues, whoever was left to, if you had any issues, go ahead and type something in the chat, and then I'll collect your emails, and we'll just form a huge email group to the IT team, and then ask them to investigate this and ensure it doesn't happen next time.
Sounds good. Yeah, if I can practice before the next session, I want to, but
Absolutely.
we'll see what happens. Thanks so much. Appreciate all your time on this.
Yeah, absolutely, guys. Yeah, so again, if you had any issues, Elizabeth, I have you. Daniel, I know you had it. Ty, I know you had it. So and then Dan, I know you had it. So I'm going to CC you guys on an email to the IT team, and then hopefully they'll help everyone out. If no other questions, guys, have a great day.
Thanks, you too.
Thank you. You too. Bye.
Yep, bye.
Hi, Matty.
Yes.
Can I share screen and then you help me to
Yes,
fix this
absolutely.
issue?